Okay, in this problem, we are going to find the first and second derivative of this function at 27, and then determine whether f of x is increasing or decreasing, those are the two options here, at an increasing or decreasing rate. We'll see. So this is a multi-step problem. So first we're going to find the derivative. We'll start with that. So if f of x equals -6 times the cubed root of x, we need to write that first with an exponent because we don't have a rule for cubed roots, but we can differentiate it if we write it as -6 times x to the power of 1/3. So then the first derivative, using the power rule, we'll bring that 1/3 down out front, so it's -6 times 1/3 times x to the power of 1/3 minus 1 is -2/3. And let's go ahead and simplify that because -6 over 3 is -2. So it's -2 times x to the -2/3. So that's the first derivative, and let's go ahead and find the second derivative also. So I'm differentiating this now. So it's going to be -2 times, use the power rule, bring this power down. So -2 times -2/3 times x to the power of -2/3 minus 1. In my head, I'm thinking -2/3 minus 3/3, which is -5/3. And if you need to do that on scratch paper off to the side, that's fine. Okay, then simplifying, the negatives cancel, and we get 4/3 times x to the -5/3. Now let's go ahead and plug in 27 into each of these. So I'm going to go ahead and find f prime of 27 and f double prime of 27. And we're actually looking to figure out whether those numbers are positive or negative. That's going to tell us information here. So when I plug in 27, okay, we have -2 times 27 to the power of -2/3. Well, I suppose you could enter that on a calculator, but I'm going to do it without one. So I'm going to rewrite the 27 to the -2/3 with a positive exponent by putting that part in the denominator. So that would make it -2 divided by 27 to the positive 2/3. And then I'm going to figure out that number by writing it as a radical, just like it was in the original function. So we have -2 over. Now this square in the numerator, that 2 in the numerator right there, means squared, and the over 3 means cubed root. So this means cubed root of 27. Now that's a 7, 27. You could put the squared here, but I can't do 27 squared in my head. So I'm going to opt to put the square outside of the cubed root. Because cubed root of 27 I can do in my head. That's 3. So it's -2 over 3 squared, or -2/9. So that means the first derivative is negative. -2/9 right there. Which means f of x is decreasing. Your first derivative tells you whether the function is increasing or decreasing. So f of x is decreasing. Now then the second part here says at an increasing or a decreasing rate. Well, that's determined by the second derivative and whether it is positive or negative. And we'll look at a graph after this also, just to further illustrate what's going on here. So let's do the second derivative at 27 in purple. I think you could probably compute this on your own at this point, but I want to figure it out and talk about this part right here. So when we plug in 27 into the second derivative here, I'm going to go a little bit faster. Definitely pause the video and try this on your own first, okay? So it's 4/3 times 27 to the -5/3, which is 4 over 3 times the cubed root of 27 to the 5th. So I did 2 steps in one there. I put this in the denominator to make the exponent positive, and I also rewrote this third part as the cubed root. So that gives us 4 over 3 times 3 to the 5th. 3 to the 5th is a big number. I wouldn't expect you to be able to do that necessarily in your head. And actually, look, it's 3 times 3 to the 5th. So it's really 4 divided by 3 to the power of 6. So 3 to the power of 6 is 729. go, 720, so 4 over 729. So it's positive. So the second derivative is positive. So the function is decreasing, this cubed root, negative 6 times the cubed root of x, so it's decreasing. Now, for decreasing functions, there's three ways a function can decrease. It can decrease straight down, which this one's not doing. It could decrease like this. That would be decreasing, but at an increasing rate because it's decreasing faster and faster and faster and faster, or decreasing at a decreasing rate, so it's decreasing slower and slower and slower. Now, the second derivative here is positive, which means the first derivative is increasing. So it's actually, let's see, the slope of the tangent line is increasing. Or if you want to look at it in terms of concavity, it's concave up. So we have this third case right here. That's where we're at. Because the slopes of the tangent lines, these slopes are negative, but they're getting bigger and bigger and bigger. So that means it's concave up. So this one is decreasing, but at a decreasing rate because it's decreasing more and more and more slowly. And in terms of concavity, the second derivative is positive, and so this is, concave up. I can write it on the page here. So this is concave up. There we go. So it's decreasing more and more and more slowly, so it's decreasing, but at a decreasing rate.